Hi guys, and welcome back to the National 5 Maths course. In this session we're going to be looking at the second lesson on surds. So to start off this video, I'll be going over the questions I left you with, or the questions we left you with in the last lesson. If you did them, then that's great, keep progressing. If not, I do think it's a good idea to go and do them, because even if you do understand the topic, it really consolidates your understanding, so you keep that knowledge for longer. So after we've gone over those, we'll look on to the only things we have to do with surds, and that is the addition of surds and also rationalizing the denominator. We'll show you a little technique for doing this and how you can do it nice and easily. So, just being what I said before, it also doesn't hurt to go and watch back other lessons, because it will only deepen your understanding. So never feel you have to only watch the lesson once. Just watch it as many times as you need, because especially with this lesson it might get a bit complicated. So looking at our last lesson's answer, first of all, we have root 12 equals 2 root 3, root 20 equals 2 root 5, and I'm not going to go over every single question, but you can just look at the explanation, and if you don't understand it, just go on and watch the last lesson again. Anyway, root 24 equals 2 root 6, root 27 equals 3 root 3, and root 36 equals 6. You might be wondering why we put this one in here, but it's just to kind of show you what the whole point of it is. For example, root 36 could also have just been root 6 times root 6, which would equal 6, and this is kind of a little rule that we have where you don't really need to understand how, but it's kind of just an easy little trick to remember that the root of something times by that same thing again is always just whatever's in the root. So root 8 times root 8 is always going to be 8. Root 6 times root 6 is always going to be 6. So here's a little rule. Square root of a times square root of a is always just going to be a. Now, looking on to our next set of answers, we have root 40 equals 2 root 10, root 45 equals 3 root 5. Root 49 again is just 7, because root 49 can be split up into root 7 times root 7, so it's just 7. Obviously you don't have to do that, because we do know that root 49 is just 7, because 7 squared is 49. Anyway, root 54 is equal to 3 root 6, root 44 is equal to 2 root 11. Now these next questions, don't worry if you didn't get many of these, or you only got 1 or 2 of them, because it is bigger numbers, so it is a little harder, but let's take a look. Root 80 is 4 root 5, root 3 root 72 is 18 root 2, that's a bit of a difficult one. Root 121, we know it's just 11, root 90 is 3 root 10, and root 250 is just 5 root 10. Okay, so now that we've gone over those, let's take a look now at the addition of surds. So we have looked over simplifying individual surds, and now we're going to look at simplifying surds by being able to combine them, i.e. adding them, and also subtracting them. So, in this question, I'll use this example. So we have root 12 and root 27. So what is the sum of these two surds? You can have a go at this question, but basically how it works is we know how to simplify these surds. So when we simplify them down, they can both have a root 3. So 12 can go into root 3, 12 can go into 2 root 3, and 27 can go into 3 root 3. Now how this works when adding surds is it's exactly like terms, that what the square root has to be the same for both of them. If this was 2 root 2 and 3 root 3, you wouldn't be able to add them. It needs to be both the same root. So because they're root 3 and root 3, we can add them together. Now, the easiest way to do it, and the way I learn, and the way most people learn when doing this, is just treat it exactly like algebra and pretend the root is just like algebra, like a or x. What I mean by that, if we pretend a root 3 is a, then we're left with 2a plus 3a, which is easy, it equals 5a. Therefore, our answer is 5 root 3. So that's all you have to think of it. Think of 2 root 3, add 3a, just think of it as algebra, which would leave us with 5 root 3. It's as easy as that, just think of it like algebra. And then looking at our next example, if we have root 8 add root 18 add root 32, again, we can split these up all by simplifying surds like we did in the last lesson into 2 root 2, 3 root 2, and 4 root 2. And because the roots are all the same, again, if the roots aren't the same, you won't be able to do this, but they are. So we can add them. 3 add 2 add 3 add 4 is just 9 root 2. So as easy as that, just treat it exactly like algebra. So make sure to practice those, and now we'll take a look at the method for rationalising the denominator. And this is a bit more difficult. So the first question you might have is, what does that even mean? As you can remember, surds are usually irrational unless you can create a case where the number is a perfect square. So to rationalise the denominator means to turn this irrational number into a rational number, which basically means into an integer, so just a whole number. So instead of having root 8, just a nice number like 1, 2, 3, 4, 5, 6, 7, 8, so on and so on. Just not having a root there anymore. So the way we're going to do this is the rule I showed you earlier, is when you multiply a square root by itself, you just get the number in the square root. However, for a question like this, rationalising the denominator of 4 over root 8, you can't just multiply by anything because you're just changing the question. You've no longer got the question, you've just changed it into something completely different. So the only thing we can really multiply by is 1, but that's not much help. So how we're going to do this is we're going to multiply by root 8 over root 8. And then this way, root 8 divided by root 8, something divided by itself is just 1. So that's fine, because we're only multiplying by 1 really. And root 8 times by root 8 is just, as we know, going to be 8, and then will give us a rational denominator, because when we multiply fractions, we multiply top and top and bottom and bottom. So looking at that, and again, this is just because 1 equals root 8 over root 8. So we're only really multiplying by a different version of 1, because this is still 1, and we can multiply anything by 1, because anything multiplied by 1 is just itself. So all we're really doing is changing the form. 4 over root 8 and our final answer will equal the same thing in our calculator, because we only multiplied by 1, it'll just be in a different form when we have rationalised the denominator of our answer. So this could even be part of a separate question. You could get an answer like this and then be asked to rationalise your answer, or rationalise the denominator of your answer, and you can do this because you're not actually changing the value of this. This and our final answer will have the exact same value. This simplifies them when we multiply top and top, bottom and bottom, and as we know, 8 on the bottom and 4 root 8 on the top. But don't get caught out here. We can simplify further with the 4 and the 8 into root 8 over 2, and that's just because we take out 4 from 4 and 8 to give us 1 on the top, but we don't write the 1 obviously, and 8, and then 8 goes into 2. So that's how we simplify that. And then further, this is where a lot of people get caught out, because you see root 8 and a rational denominator. However, root 8, as we know, can be simplified further into 2 root 2. And then what can we do? Cancel the 2's to just give us our answer of root 2. So hopefully you understand that. If you put 4 over root 8 and root 2 into a calculator, you'll get the exact same answer, because we haven't changed the answer. We only multiplied by a version of 1, which means our answer is exactly the same. If you multiply 4 over root 8 by 1, you're going to get the exact same thing. We're just multiplying by a different version of 1 in the form of root 8. So all you have to do to rationalise the denominator is multiply by the bottom surd on the top and on the bottom. And then when you multiply by the bottom surd on the top and the bottom, simplify as far as you can, and you'll get an answer. You won't always be able to simplify as nicely as this, but do look for that, because you don't want to lose marks for easy simplification. Okay, so that's us done for today's lesson. I'll leave you with some quick questions to attempt over the addition of surds and rationalise the denominator. I'd recommend you just pause the video and take a look at these, as they don't take very long, but the value they have to your learning is worth a lot more than that. So thanks very much. Make sure to consolidate this, watch the lesson if you need to, and watch the lesson again if you need to, and thanks very much for watching. See ya.